My name is Keith Alverson. I'm head of climate change adaptation and terrestrial ecosystems here at the United Nations Environment Program. I'm very sorry not to be able to join you at the workshop on a modeling framework for addressing drought impacts in Kenya due to the fact that both me and my fellow associates here at UNEP working on climate change will be at the UNFCCC COP meeting in Lima, Peru at the same time. I wanted to take the opportunity, first of all, to thank Datu Augustinata for the invitation to UNEP to participate in the workshop, which we're unfortunately not able to do, but also to participate in the longer-term activities of the group as we move forward. I'm going to talk a little bit then on substance. First of all, a couple of slides I'd like to show you. The first one is the observed change in mean annual precipitation taken from the IPCC Working Group 1 summary of the 5th assessment report. You see two pictures. One is the observed precipitation change from 1900 to 2010, and the other is the second half of the century from 1950 to 2010. The thing you'll notice in Africa in both these slides is there's very little data. Most of the map is white, meaning from the instrumental record we do not know what the precipitation changes have been in Kenya. We do not know the natural variability of precipitation over the last 50 to 100 years. Looking only at the data we have best, 1950 to present, the picture in Kenya is both brown, meaning decreased precipitation, and blue, meaning increased precipitation, at the level of the pixel of the IPCC report. Meaning that the situation is quite complex and is not captured by this level of simplification. The second slide that you'll see is a picture of the annual mean projections from models. On the left, you see the data that I already showed you from 1986 to 2005. And on this right, you see the projections for the decades 2081 to 2100. In this, you see a strong indication of increased precipitation in East Africa, so far wetter conditions. Now, this might lead to a tendency to say, well, why are we worried about drought? And one of the take-home messages from my brief talk here is that that is not the case. Even in a situation where you have climatologically increased precipitation, as IPCC models project for Kenya, you can still have periods of intense drought and impacts thereof. In the third slide, I show you the projected model precipitation changes seasonally. So rather than looking at the annual mean, look at the seasons. On the left, you see December, January, February, and on the right, you see June, July, August. Here you see that this increased precipitation projection is mostly for the December, January, February period. And that if you look at June, July, August, the situation is quite different. Those are the projections, again, for comparing recent data with projections for around the year 2100. In the next slide, I want to break down now from either looking at annual or seasonal thinking to looking at very specific interannual variability. And this is the El Nino La Nina phenomenon. It's a phenomenon that is not well captured in models. The IPCC 5th assessment report calls it poorly constrained for projections. Nonetheless, the teleconnection patterns impact on Kenya. During an El Nino, we see wet conditions in East Africa. And during the La Nina cold phase of this oscillation, we see dry conditions in Kenya. Both of those are concentrated on the December to February time period. Now the next slide is something I just took today from the real-time data available on the web for what is the El Nino pattern right now on the 7th of October. You can see that we are headed about halfway into a 1 degree increased temperature anomaly in the tropical Pacific. This is the Nino 3.4 index. And projections give us roughly a 50-50 chance of going into a full-blown El Nino or not in the coming 2 months in Kenya. If we go into El Nino, as we did in 2010, or as far back as 2002, the large El Ninos, there will be massive flooding in Kenya. We have a chance of that occurring now. We don't know if it will occur, and so it's very difficult to put in place actions on the ground which respond to this unknown but possibly very large flooding situation in Kenya in the next 2 months. This is something that UNEP and other agencies are currently working on, thinking about how we can develop better resilience to possibilities of flooding and drought in Kenya. Now, the next slide, I want to look at the past. I showed you that the current data for flooding and drought in Kenya is limited because the instrumental record is quite short. This shows you an attempt using historical data to reconstruct the level of Lake Naivasha, a lake quite close here to Nairobi, over the past 1880 to 1990. And you can see, if you look on the right side of that curve, the instrumental period from 1950 to present, there has been very little change in the lake level in Naivasha. But looking back, you have very good evidence. One picture shows a boat dock that is now located 6 meters above the current lake level, and another shows from the 1950s fence posts going into the lake, where clearly the lake was at least 1 meter below current levels in the 1950s. So in the last few centuries, the lake level has changed dramatically, indicating changes in climate on those same timescales. In the next slide, I show you even further back, an attempt from lake sediment cores to look at how has been the hydrological change around the Lake Naivasha catchment area over the last millennium. Here you see very strong evidence for 100-year wet flooding conditions, 100 years long, from 1600 to 1700, and similarly 200 years of drought from the year 1000 to 1200, where the lake levels were a full 40 meters below current levels. So that means that within the natural climate variability of the Kenyan region, we could expect a century-long drought with lake levels 20 to 40 meters below current. And that's not even putting into the picture possible anthropogenic or existing anthropogenic climate change. It's just the natural variability of the hydrological system in this region. It's scary. That's a long drought. At the same time, with this large natural climate variability regionally on the hydrological system, the last slide shows you that, in fact, climate change is even though I just argued it was enormous, it's small compared to other changes in the system going on now. So the slide shows you, for example, that the population in this area around Nairobi over the last century has gone up by a factor of 25. The amount of cropland has gone up by a factor of 5, and the amount of pasture taken back from natural ecosystem has gone up by a factor of 8. These are enormous changes in the ecosystem and in the social dynamics that have occurred over the last 100 years, which in fact dwarf the natural climate variability in terms of their impacts on the availability of water and the demand for water, particularly in a period of drought. So let me conclude. It's great that we're embarking together on an effort to use numerical modeling to understand climate variability and the impacts of drought in Kenya. At the same time, we have to be conscious that numerical modeling of climate variability is only a small part of the picture, that natural variability in the past and social economic changes in the current and future are strong drivers on the impact of drought here in Kenya. Thank you for your time and enjoy the meeting.